Hi, in this video, we'll take a look at NAT operations for IPv4 and terminology. Okay, so why NAT? All right, the bottom line is that running out of IPv4 addresses. This started way back in the early 1990s. So remember, that's when people were getting a lot of PCs, personal computers. They'd been out for about 15 years, but they were just becoming popular. And for one of the main reasons was the World Wide Web. So it was recognized early by ISOC and IETF that we're running out of IPv4 addresses. So in the short term, NAT for IPv4, along with private IPv4 address space. Classless interdomain routing, so we moved away from just having basically three classes ABC of user addresses and finding better ways to allocate IPv4 addressing space more efficiently. But the long-term solution was is IPv6. NAT is one of them, because NAT actually kind of kept the depletion and exhaustion of IPv4 at bay for a long time. The movement to IPv6 really stalled for about 20 years and is now gaining a lot of momentum, and we basically have no choice but to move to IPv6. You know, I'm a big proponent of IPv6, but I'll save all that for other videos. Okay, so talked about the internet concerns, okay, and how we solve that. Let me get past all that. Private IPv4 address range. So the idea was that internally anybody could use any of these addresses within these three ranges. Yeah, but these addresses were not routable. So service providers, when they receive if they receive an address with a source or destination with a private RFC 1918 address, it should be dropping those packets, which means they need to be converted. Okay, so by the NAT device, typically a router. All right, so let's get past all this. Here we go. So we need a device to translate those private RFC 1918 addresses to a public routable address. Okay. So this makes IPv4 addresses pretty much only locally significant in customer networks. Okay. So in the public IPv4 address space, so here you have, over here you have your Amazons, Facebook, Google, your web servers, everybody you're trying to access, maybe cabrillo.edu, ucsc.edu, or whoever, but everything that is publicly accessible. All the clients and including businesses' internal device space is all inside private IPv4 address space. Okay, so that means that we need to be converting those source addresses to public addresses coming out, and then when they come back as a destination address, converting them back to the private address. Okay, so NAT is not security. Right? A lot of people think, oh, I get rid of NAT, I'm no longer secure. So let me ask you, do we have problems? So now that we've been doing NAT now for 20 years, that means any devices you have at home or at work, we don't have to worry about security, right? Because NAT is security. No, NAT is not security. And anyway, a friend of mine did a great video that you may want to check out. A fanboy series, IPv6 and NATs. All right. So NAT has been used just to hide customers from the public internet, but it also creates a lot of issues and breaks a lot of applications. Okay, so and using NAT to hide IPv6 networks doesn't exist, has been the source of some debate whether we should allow some form of NAT for and private addressing with NAT for IPv6. That's a later video, but pretty much the overwhelming response has been no, let's not go back there. It breaks too many things. Okay, all right. So there's also the issue where, because we're using private IPv4 address space in the customer environment and typically be translated to a public address as it hits the provider's network. The problem is with providers are running out of public IPv4 address space, so they're converting it to another group of private IPv4 addresses that then get translated finally to the public address as it leaves their space. So this is known as large-scale NAT or carrier-grade NAT or NAT 444 because we're using 3 groups of IPv4 addresses. We got private, and public. So it's just become a mess, and it's really hard to manage this and breaks even more things. Okay. So that's the actual range that the an ISP can use for its own IPv4 private address space. So converting it from private to public, then public to private to private. Not good. A lot of latency involved as well. All right, so here's an example. We're a packet leaving the XYZ network with a private source IPv4 address, that's RFC 1918. Okay, the router is going to translate that to some public IPv4 address, so it gets translated to a public IPv4 address. Comes back to this public IPv4 address, and the router will translate it back to the proper private IPv4 address. And how we do that, okay, is done one of 3 ways: statically, dynamically, or with port address translation. We'll talk about all 3. But let me talk about a little bit of terminology. Okay, so we have both an inside network. Let me see, oops, sorry, this kind of went a little fast here. Let's see if I can, there, inside network and an outside network. All right, so the inside network, this is Cisco's NAT, it's NAT terminology in general. The inside network is the set of devices using the private address space, which is going to be translated. The outside network refers to all other networks. This is all going to make more sense as I show you some examples. Okay. Just let me get through the actual terms here and then I'll explain them. An inside address, the address of the device being translated. The outside address is the destination device, which is typically, if you're trying to reach something outside your own network and it's being and you're using NAT, this is going to be a public IPv4 address. Okay, so NAT also uses the concept of local and global. So local is any addresses that appear on the inside part of your network, and global is everything on the outside. Okay, so let me kind of explain these. So here we have PC1 with a private IPv4 address. We have our server, web server, with a public IPv4 address. Our router also has a public IPv4 address facing the outside network that it's going to use to translate. This is going to be the address used by our devices on the inside. This is the address PC1 is going to get when it sends packets to the outside network. So looking at this, the inside local address is that of PC1's, its private IPv4 address. The outside local address, so this is actually the web server's address. So it's looking at this address locally on PC1, but what's the outside address? Where is it? Where is this packet going? Inside global address. So what is the address that PC1 is going to use when it sends packets to the outside world. So it's getting translated from the inside local to this inside global. The outside local is the same as the outside global. That's just a public IPv4 address, so that doesn't change. But this is what changes, the inside local to an inside global. Okay. So a lot of times when you look at Cisco iOS NAT tables, this is the terminology that they're using for their NAT tables. Okay, 3 types of NAT applications, and we're going to take a look at each one in a separate videos. Static NAT, dynamic NAT, and port address translation. Really, the 2 that are used the most, port address translation and also static NAT for along with port address translation. These will all make sense in the upcoming videos.